think we've got who we're going to get today. So I will submit. Let's begin. Good afternoon, everybody. A casual reminder that the best steel doesn't always shine the brightest. Okay? We don't all have to be the brightest in order to be the best. Steel, of course, has many other qualities that make it useful and pretty darn good, right? It can be very strong, tough, flexible, actually. That's very useful, particularly like with swords, that it's kind of springy. All right, so don't get caught on just one judgment of goodness. Anyways, today we are going to review the review. We'll go over the answers, and then you'll probably have a little bit of class time at the end to study on your own for the upcoming test. So before we begin, a few details on said test. It's coming in 2 parts. First part, the writing portion will be on Wednesday. All color groups, that mean you guys even yet again are required to attend on Zoom tomorrow on Wednesday during your scheduled class time. Because that's when I will put out the assessment. I will post it on Google Classroom at the beginning of class. You will have until the end of class to turn it in and have it count as on time. Right? If for whatever reason you have some scheduling conflict because you knew in advance, oh, we weren't going to have class that day, you got a dentist appointment, whatever, today is your last chance to tell me ahead of time so that I can excuse that for you and set up an alternative time for you to take that portion of the assessment. All right? That part, as I said, it's the writing portion. So briefly looking ahead, it looks very much like these last couple questions from the review. That is to say, there will be one where you'll read through a paragraph of an argument and you'll have to answer it and explain your reasoning, okay? Why you think it's such. And there will be another one that is a complete argument that you will have to translate into symbolic form and justify each portion thereof, i.e. writing a 2-column proof like we do on here. Okay? That'll be what happens tomorrow. The rest of the questions will show up in one form or another on Friday's portion. That'll be the multiple choice / short answer. That's going to be a Google form. Again, you will join the Zoom on Friday. You will have your camera turned on the whole time so that I can see it's you and only you working on this. Combination of multiple choice and short answer covering the rest of the types of questions from here. Let's see, you will be allowed your notes. It is an open note test, but they have to be hard copy notes because your machine will be locked into using the Google form, right? So if you have electronic notes, you've got to make hard copies. Either print stuff out or recopy it down by hand. Doesn't matter. They got to be on paper. You will technically be allowed to use a graphing calculator, but I really don't think that's going to be at all useful on this test because there's almost no computation in that regard. So, but that is allowed. Okay, let's see. I got everything on Friday. Class time. Time element, what you're allowed to use. I think that covers it. Any questions regarding the test itself? What's coming up? What to expect? How does it work?
I have a question.
Go for it.
You said it was going to be significantly shorter. Is it actually going to be short, like just like some questions of these, like on the logic and reasoning unit review?
Yeah, well, for the sake of review and for giving you practice, I have many questions of the same type, right? I mean, there's 8 of these kinds of guys. There's probably only one on the test. I'm aiming for around 10 questions. I haven't finalized my list yet, but it might be like 10, 12 questions at the most. Okay? Friday's a short day. You only have the 40 minutes to complete it. All right, thank you. That was a good question. And let's see, I thought I heard a ding-in. Who came in? Andre's here now. Excellent. Take that. All right, any other questions about the test itself before we go through the review? Christian says, hey. Yeah, keep going. All right, well, I await his question to appear. Go ahead and take out your review and start checking your answers. The first section of which was categorizing the disciplines into pure or applied. This is straight from that video I shared on the types of math. Oh, he doesn't have a question. Okay, just wanted to say hey. Hey, Christian. How you doing? Thanks for tuning in. I don't think I marked you absent or anything, right? He's here. Yeah, okay. All right. So just going through that video, what is where? Linear is pure, optimizations applied. Topology is pure, numerical analysis applied. Cryptography applied. Chaos theory, pure. Pretty much anything that ends in theory is probably going to be one of the pures. Okay. Group theory, pure. Statistics applied. Set theory, pure. Computer science applied. Engineering applied. Combinatorics, pure. All right, next one. This is from the blog post from Math with Bad Drawings, describing the branches of math with one word, or each math class with one word. Algebra is the math of relationships. Geometry is space. Calculus is change. Trigonometry is position. Probability is uncertainty. Statistics is populations. And logic is truth. All right. Any questions from either of those sections? All right, the next section was pretty tough. I'll be honest. A lot of these have quite some crossover. You know, for example, making use of structure and repeated reasoning can sometimes look pretty similar in practice. So I wouldn't knock it if you had, switched a couple of these up. But this is taken word for word straight from the official Common Core description of each mathematical practice. And so there is one for which each example best fits. So making sense of problems is example 5. Reasoning abstractly is example 6. Constructing viable arguments is example 2. Modeling is 1. Using appropriate tools is 8. Attending to precision is 3. Making use of structure is 7. And expressing repeated reasoning is 4. If such a question does appear on the test, it will be a lot more clear what you're matching to or how you're defining it. So don't be too scared off by these ones. All right. Any questions on that section? All right, next up, Math Thinking Fundamentals, straight from my playlist of videos. Quantity is the fundamental of size, amount, distance, and measurement. Shape is space and visual representation. Relationships is connections between ideas. Variables is substitution symbols, reasoning abstractly. And inverse is working backwards. All right, in the next section, I do apologize for the cutting off of some of the edges of some of these numbers. You see like the little 3 there is only half there. I screen grabbed the whole block of questions here from the textbook, so that is in their printing there. For some reason, the blanks got smudged over a bit and overlap the numbers. So if, for example, you had 8 plus 5 is 13. Like this should be a 13 in here. If your two numbers were the 13 and the 21, I would accept that because this was a little ambiguous as to which one was truly the next to be listed. But otherwise, most of these are fairly straightforward. This is just multiplying by 10 each time. Here we're just subtracting 4 every time. Number 7 is a super awesome sequence. This is the Fibonacci sequence. Every number is the sum of the two numbers that appeared before it. So 1 plus 1 gives you 2, 1 plus 2 gives you 3, 2 plus 3 equals 5, and so on. It's a really cool sequence. It appears all over the place in a lot of nature stuff, actually. These numbers appear. You'll be like counting petals on flower plants and be like, oh, they arrange themselves in groups of 3, 5s, and 8s. Crazy. So really cool sequence to know. What else? Let's see, 4 was a little challenging. Recognize everything can be represented with a common denominator over 6. So this is counting up numbers of sixths. This is 1 6, 2 6, 3 6, and so forth. Number 6, there's the triangular numbers again. 8, these are the squares. 10, here's powers of 2. All good sets of numbers to know, recognize, come to love. For the drawing, here are my next shapes. We go up to a 5-sided figure with all the diagonals connected. We've got a rectangle of 7 across and 10 high squares. We've got now 4 columns of steps here. We've got next level a little branching fractal tree there. Here's the super duper duper triforce down here, Sierpinski's triangle. And now we've got a row of 4x4 circles inside squares. All right. And then last question on that page. When you use inductive reasoning, you are generalizing from careful observation that something is probably true. When you use deductive reasoning, you are establishing that if a set of properties is accepted as true, something else must be true. Definitely need to be able to distinguish between those. Okay. Any questions from that page? All right, moving on. Here we go, true or false. If false, why? Number 1, the disjunction, that is fancy word for an or pairing of P and Q, is true whenever P is true and Q is false. If I have or, I only need one of them to be true. So P is true, Q is false. Yes, the whole thing is true. That checks out. 2, if the conditional if P then Q is true, then the conditional if not P then not Q is true. That is false. Notice it goes from P to Q. From P to Q, the same order is kept. They've just negated both sides. That's the inverse. Inverse of a conditional is not automatically true. If you reversed the order and negated, you have contrapositive. That would be true. All right, 3, I am older than 20 or younger than 30 is an example of an exclusive or. Exclusive or meaning you can only have one or the other. You couldn't do both. That is false. You can totally be both older than 20 and younger than 30. In fact, I am. For converse of if P then Q is if Q then P. That's true. 5, if P then Q means P is necessary for Q. False. False. Okay? This does not automatically mean you need to have P in order to have Q be true. It is one way that leads to Q, but it is not necessarily the only way. But it does mean if you wanted P by itself, you would need Q. So that reversal is implied. All right. Any questions from that section? Okay. Next, the converse, inverse, and contrapositive of each statement. Converse, reverse the order. So we started with P, then Q. We reversed it to Q, then P, keeping the negation symbols in place. Inverse up next. Keep the order the same, but negate everything. So P becomes not P. Not Q becomes not Q, which is just Q. And contrapositive, do both. Reverse the order and negate everything. So we get Q, then not P. And you can see what happens to the other combinations as follows. Any questions there? All right then. Number 7. True or false? Well, we got to look at the conjunction or the combination word in between. How are these two statements combined? 4 plus 7 equals 11. That is true. 1 plus 5 equals 6. That is also true. And I need both of them to be true. That is what's happening here, so the whole thing is true. B is a biconditional. That means I can go in either direction, and I have to make sure we've not broken any promises. That is to say, if you start with a true statement and imply a false statement, the conditional is false. It doesn't hold up. So 2 plus 5 equals 7. That is true. 4 plus 2 equals 8. That is false. This biconditional means I can go from the true to the false. So that condition fails. The whole thing is false. C, 3 times 5 equals 12. No, it doesn't. That's false. 2 times 6 equals 11. Also false. So even though I had two options, both of them were false. So or, I only needed one. I didn't get anything. Whole thing is false. D, 2 plus 3 equals 5. True. Then 1 plus 2 equals 4. False. I said if a true statement, then a false statement. You broke your promise. No good. It's false. E, if 3 plus 4 equals 6, that's a false statement. I'm starting with a falsehood. Anything could follow from that. There's no way to disprove it. Right? This is already false. It's like saying, if pigs fly, then it doesn't matter what you said after that. The pigs flying is not happening. So the conditional is true, whatever this says. I don't even need to check 8 times 4 equals 31. False, by the way, but it doesn't matter. Whereas if 7 is even, which it's not, that's false. So even though the 8 is even being true, if I start with a false premise, if something false, then whatever follows, the whole conditional is true. Any questions on that section? All right, up next, they recommended using an Euler diagram here. I did not include one for each one, but if you would like to see one, we can draw it live. Just let me know. So A, some men are teachers. Sam Jones is a teacher. Therefore, Sam Jones is a man. Invalid. Okay, just because you landed in the teachers. You didn't say all the teachers were also men. Right? There's some overlap, but it's not one group totally encompassing the other. You're not automatically a man. That's invalid. B, gold is heavy. Nothing but gold will satisfy Amy. Hence, nothing that is light will satisfy Amy. Well, if it's light, it's not heavy, right? And if it's not heavy, it can't possibly be gold, because gold is definitely heavy. So it's whatever that thing is, it won't satisfy her, because only gold does that. So that is totally valid. C, no cats are dogs. Okay. All poodles are dogs. Good. So some poodles are not cats. Well, yeah, I would actually probably say all the poodles are not cats, but this is good enough. That is a valid argument. The poodles land in the dogs, and there is no overlap between cats and dogs, so it can't possibly be a cat. Got it. D, some cows eat hay. All horses eat hay. Only cows and horses eat hay. Oh, so they're the only possible things allowed to eat it. Got it. Frank eats hay. So Frank is a horse. No, so close. That's invalid. If you know he eats hay, and cows and horses are the only things that eat hay, all you can conclude is he must be a cow or horse. You can get that far. But you can't determine which one, because there's no exclusivity between the two. We know that some cows do, and all the horses do, but just from hay doesn't let us narrow it down which one it is. Okay, any questions on that section? All right, next up. Determine your own valid conclusion if possible. All polyhedra have edges. A tetrahedron is a polyhedron. And as long as the Greek pluralization, hedron, hedra, doesn't throw you off, you could recognize that that means this thing is in that category has this property, therefore a tetrahedron has edges. And that is, in fact, a version of modus ponens. Okay. However, B, if it is 5 p.m., then it is quitting time at work. It is 4:15 p.m. What does that mean? I have no clue. That tells me nothing. I only know about the specific time, 5 o'clock p.m. I have no idea if that's the only quitting time, right? Maybe the earliest quitting time is actually 4 o'clock, and so if it's 5 o'clock, it's actually well past quitting time. If you're still there at 5 o'clock, you should go home. I don't know that, right? So 4:15 tells me nothing, because I didn't say only 5 p.m. So there is no valid conclusion there. Questions on those?
Is this going to be like, all right, so for like the test, do we have to explain like why?
All right, now for the big one. Get the whole thing on screen here. There we go. Coach Schwartz told his starting 5 Wednesday evening, if any of you don't come to practice tomorrow, then you won't play in Friday's game. Darlene is one of Coach Schwartz's starting 5. She came to practice on Thursday, but she did not play in Friday's game. Did the coach break his word to Darlene? Explain. Did he break that promise? What he promised was if you don't come to practice, then you won't play. If you think he broke his promise, then you're assuming if you do go to practice, then you will play. That would be the inverse of the statement. That is not automatically true. Okay? No, he did not break his promise, because not coming to practice is not the only way to not play Friday's game. Okay? If you assumed as such, you would be denying the antecedent, right? Assuming that the inverse is true, you're saying, oh, well, I negated if I don't come to practice, that is to say, double negative, coming to practice, concludes the negation of the conclusion, not automatically, right? There's more than one way to not play the game on Friday, right? Not showing up to practice was one of them. Breaking your leg could have been another, right? Being late, being, sick, roster changes. You get there and then it's like, oh my gosh, we're actually playing this team and they've subbed this person in for that position. You're going to sit this one out and we're going to start with the other person because they're a better matchup against that guy, right? You don't know. Not enough information. Okay, questions there? All right, that final one. Translate the English argument into symbolic form and then justify that the argument is valid. In order to justify that the whole argument is valid, you must provide reasoning for every statement involved. The simplest way to do that would be to write a 2-column argument here. And so first you must identify which statement is represented by which letter. I chose 60 out of 104 majors at the local university require calculus to be letter M for majors. I assigned calculus is an important class to take in college to letter C for calculus. And high school students should take all the math necessary to enter a calculus class is statement H for high school. So what was given were these first 2 conditionals, if M, then C, was that first sentence? Next up, they told us if C, then H. That was another given in premise. The third sentence down here, in fact, 60 out of 100, oh, they just restated M. So my fourth statement here is M as the third given or premise. You can use either word there. Notice what they skipped over. They did not explicitly restate this statement. If M, then H, that shortcut version, right, law of syllogism. We need that piece written out for our justification of the argument, because you can't apply modus ponens to two conditionals at once. So we condense it down to one, then combine with the single statement to conclude, therefore H, as they have done, therefore high school students, right? Or, if you don't like law of syllogism, you could have just done modus ponens twice. So, okay, M with M then C, and then you'd have, your statement would be conclude C all by itself, and then you can combine C with if C then H, modus ponens again to get H. So there is another way of doing this. Okay, any questions there? No? Any questions anywhere else? Any confusion? Any hesitation? Or are you ready to take the test? Ready to go? I have tomorrow's piece written. We can start now if you'd like. No? All right. Well, then you have the rest of the period to work independently, whether that is studying and preparing for this test, or if you have work from another class, you can work on that, I suppose. As long as you've got this done, I don't have additional work for you unless you specifically request it. All right?